Since in the last video we left off with a couple important trigonometric limits that you're going to see throughout your studies in calculus, in this video we're going to consider a simple example that uses one of those limits. So we're going to be finding the limit as x tends to 0 of sine of 4x over 2x. And when you look at this, you'll see this bears some resemblance to the limit as x tends to 0 of sine of x over x, but it doesn't quite look the same because you have a 4x in the numerator and a 2x in the denominator. But we want to somehow turn this into something that looks more like sine of x over x. And I'm going to show you how we go about doing it, and then I'll explain why what we did works afterwards. So what we're going to do is we're going to let u equal 4x and use just another random variable here, and we're going to write everything here, rewrite everything in terms of u. So if u is 4x, then that means, and this symbol here usually means therefore, x is 1/4 u. So this limit as x tends to 0 of sine of 4x over 2x is a limit as 1/4 u, because remember x is 1/4 u if u is 4x. Limit as 1/4 u tends to 0 of sine of u divided by 1/2 u. And the 2x becomes 1/2 u, because if u is 4x, then 2x is 1/2 of that, or 1/2 u. So we have the limit as 1/4 u tends to 0 of 1 over 1/2 times sine u over u. And all I did here was I rewrote this 1/2 with a numerator of 1, and you'll note that this is 2. 1 over 1/2 is 2. And the limit of a constant times a function is a constant times the limit of that function. So we can write this as 2 times the limit as 1/4 u tends to 0 of sine u over u. And again, that's because 1 over 1/2 is equal to 2, and 2 is a constant. The limit of a constant times a function is that constant times the limit of the function. Okay, and before we go any further, you'll see we have the limit as 1/4 u tends to 0. So how do we really interpret that? Well, I'll first make this point here. As 1/4 u tends to 0, u also tends to 0. And to explain that, I'll just show you a chart here. Let's say on the x-axis, I have the variable a, and on the y-axis, I have the variable 4a. You'll see for every unit on the x-axis, or we'll say I have the variable y, which equals 4a. So for every unit I move in the x direction, or for every unit a I move 4a in the y direction. So this should look more like a straight line here. Okay. So as I'm coming from negative values, as x gets closer to 0, well, y gets closer to 0 4 times as fast, right? Because the slope of this line is 4. And coming down from positive x's, as x gets closer to 0, y gets closer to 0 4 times as fast. So as a tends to 0, 4a also tends to 0. 4 times as fast, but nevertheless tends to 0. So that shows you that whatever happens as 1/4 u tends to 0 also happens as u tends to 0. So therefore we can write this limit 2 times the limit as 1/4 tends to 0, 1/4 u tends to 0 of sine u over u. That's equivalent to 2 times the limit as u tends to 0, because remember, whatever happens as 1/4 u tends to 0 will also happen as u tends to 0 of sine u over u. And this is basically, well, this is exactly limit as x tends to 0 of sine x over x, but instead of x you have u. And that's 1, right? So we have 2 times 1, and that's equal to 2. And we had just made the substitution u equals 4x. Now let's see why we did that. We wanted to turn this sine 4x over 2x into something that looked like sine x over x. And when we see something of this form, we always let u equal the argument of the sine function, and then we manipulate the denominator to make it look like sine u over u. So when we did that, this became 1/2 u, and 1 divided by 1/2 is 2. The 2 could be pulled out here, because the limit of a constant times a function is that constant times the limit of the function. And we were thus able to get this into the form sine u over u. And we're able to see that that limit is 2. The next video we'll look at another trig limit problem.